I did this video just to remind myself how this Z80 microprocessor works. Here is the Z80. It has a program written in assembly and stored in this EEPROM. I have a 16 LED array that is connected to the address bus. I have a display connected to the data bus, but only these two ones are actually active. It's accessed when any port is accessed by the microprocessor. I don't have a decoder specially created for this, it's just connected there. I have one LED here that shows the state of the M1 pin of the microprocessor. The M1 pin here is used by the microprocessor when it fetches a new instruction from memory. The program stored in the memory is as follows. It loads a number, in this case 5, into the register A, shows it in a port, increments that number, and again shows in a port. In this case I'm using port 2, but it could be any port, at 3, and it jumps to main in an infinite loop. What I wanted is to slow down the operations so much that I can see and understand how many clock cycles each operation takes. I wanted to see what is written in the datasheet and how it coincides with the real microprocessor. I created a manual clock here with its button, but it's not working well. So I'm using instead this Arduino, and I'm using this as a clock generator, but it's still a manual clock generator. I'm going to send in the serial port with this. Every time I will send something, it's going to send a pulse to the microprocessor. That's going to be the clock, a manual clock. The first instruction, load a number into register A, here in the datasheet, says that it takes 2M cycles divided into parts, one of 4 T states and the other 3 T states. So I'm going to turn on the computer. Now I need to reset it. To reset, I need to use 4 clock cycles while pressing the reset button. 1, 2, 3, 4. That's it. Now we're ready to use for the first instruction, that is load 5 in register A. It uses 2 M cycles divided in 4 and 3 clocks. So 1, 2, 3, 4, and 1. As you can see, the M1 is activated, so it's fetching the number 5 from memory. 2, 3. Okay, and it has advanced the address. Now we're going to show the value in register A in port number 2. So it's going to take 3 M cycles divided like this, 4, 3, 4. 1, 2, 3, 4. 1, 2, 3. And the 5 should show now here. 1, 2, 3, 4. That's it. 5 is there. We are going to increment the value in register A. It's just 1 M cycle, and that's 4 clocks. 1, 2, 3, 4. And we're going to output that value in port number 2. That's 4, 3, 4. 1, 2, 3, 4. 1, 2, 3. 1, 2, 3, 4. Yeah. 6. Increment the value by 3 and jump in an infinite loop. And I think you get the idea.